Hello friends, welcome to engineering tutorial. Now in the previous videos we discussed about mesh analysis. In previous videos related to circuit theory I'm talking about, okay? In previous videos related to circuit theory we have discussed about mesh analysis. We discussed about the basic concepts related to mesh analysis. We discussed about mesh analysis involving current sources. We discussed about the concept of super mesh. So now we will discuss the other method of basic circuit analysis, which is nodal analysis. Okay, this is another method of analysis of a electrical circuit. So the nodal analysis it is actually based on Kcl, okay, Kirchhoff's current law. The mesh analysis which we studied it was based on KVL, Kirchhoff's voltage law, but the nodal analysis it is based on Kirchhoff's current law. Okay, we all know what is Kirchhoff's current law and Kirchhoff's voltage law. Okay, KCL, summation of currents at a particular point is 0. KVL is the summation of voltages, and voltage drops across circuit elements in any closed path is 0. Okay, so this is very important. Nodal analysis is based on KCL. Now, from this word nodal analysis, the one thing which strikes out is node. Okay, nodal analysis is all about nodes and applying KCL at those particular nodes. Okay, so how to identify a node? Okay, let us draw a circuit. Okay, a voltage, this is just a random circuit I am drawing, okay, just to make you understand the concept about nodes. Okay, this is R3. Okay, now here we have to identify nodes. Okay, now if I say you tell me what will be the voltage at this point, what will be the voltage at this point? So here you can see this point is connected to this voltage source V1 and there is no other circuit element, be it a resistor, inductor or capacitor connected in between these two points, that is in between the voltage source and this point. So there will be obviously no voltage drop. So there will be no loss of voltage in between this voltage source V1 and this point. Let's call it point 1. So in between point 1 and voltage source V1, there is no loss of voltage because of any circuit element, because there is no such circuit element present in between them. So the voltage at this point 1 will be V1. Okay. What will be the voltage at this point? Okay, we have already found out that the voltage at this point is V1. Now, see, in between these 2 points, is there any circuit element present? Resistor, inductor, capacitor? No. As no circuit element is present, no loss of voltage, no voltage drop. So the voltage here is also V1. Now, if we have to determine the voltage here, okay, in between voltage V1 and this point, there is a resistor R1 present. Okay, here in between this voltage, independent voltage source V2 and this point, there is a resistor R3 present. In between this point, which let us say we name it as 2, and this ground, which means 0 volt, there is a resistor R2 present. So obviously in these 3 paths, 3 directions, there will be some voltage drops. So the voltage at this point 2, it cannot be V1. Because of this resistor R1, there will be obviously voltage drop across this R1. So the voltage at V point 2, it cannot be V1. Here in between this point 2 and the independent voltage source V2, there is resistor R3 present. So there will be voltage drop in this direction also. So the voltage at V2 cannot be V2, it cannot be V1, it cannot be V2, and also in between ground and this point there is a resistor R2 present. So there will be voltage source, there will be some voltage drop. Okay, there will be some voltage drop. So here it is not 0 volt either. So let us name it voltage source. Let's say we call it as V.2. As already V2 is present, I named it as VP2. Okay, so here the voltage at point 2 is V subscript P2, which is neither equal to V1 nor equal to V2. But here, as there was no circuit element present in between this independent voltage source V1 and this point and also this point, so the voltage at these points were V1. But here in between these 2 points, that is in between the point 1 and the point 2, there was R1 present. In between point 2 and ground, there was R2 present, and between point 2 and this independent voltage source V2, there was R3 present. So the voltage source, the voltage at this point, it can neither be V1, it can neither be 0 volt, it can neither be V2, because there will be some voltage drop across the resistors R1, R2 and R3. So we named it as VP2. Okay. Now coming to the question of nodes. The definition of a node. Okay, how can we define a node? A node is a meeting point. Okay, a node is a meeting point of one or more circuit elements. Sorry, it's not one, it's actually 2 or more circuit elements. Okay, it is a meeting point of two or more circuit elements. Now the circuit elements, it can be a voltage source, it can be a current source, it can be a resistor circuit element, it can be an inductor, it can be a capacitor. Okay, so a node is a meeting point of two or more circuit elements. Okay, it can be a voltage source, current source, resistor, inductor, capacitor, or any other circuit element which obeys the basic uh, linearity and homogeneity principle. Okay, so here is the basic concept about nodes. The important thing to remember is to identify the node voltages, that is, if in between 2 points there is no other circuit element present, that is power absorbing circuit element such as resistor, inductor or capacitor, the voltage in between those 2 points will be the same voltage will appear at those 2 points, and if in between 2 points there is a circuit element present, be it a resistor, inductor, capacitor, the voltages at the 2 points will be different. That is, what I am trying to say is that simple, just remember these two concepts. If there is a short circuit between 2 points, let us say 1 and 2, no circuit element present, in that case the voltage at points V1 and 2 will be the same, V1 will be equal to V2. But if there is a circuit element present in between points 1 and 2, there is a circuit element present, be it R, L, C, which absorbs power, which absorbs there is a voltage drop across it. In that case, V1 will not be equal to V2. Okay. Now, how to apply nodal analysis? Okay, let us understand that. Okay, so now we will understand how the nodal analysis is actually applied in a circuit. Okay, so I have already told you that nodal analysis is actually based on Kirchhoff's current law. Okay, so it is basically applying Kcl. The summation of currents at a point is equal to 0. So here that point is the node, specific nodes. Let us consider this simple circuit. Okay, it has a independent voltage source, an independent current source, 3 resistors R1, R2, R3. Now here this is a node, it is a meeting point of many circuit elements, not just two, many, R1, R2, R3. There is a voltage source and current source involved indirectly, but still it is a meeting point of more than 3 circuit elements. Now, in order to apply Kirchhoff's current law, first we have to assign branch currents. Okay, we can do that arbitrarily, we can give them any direction as per our choice, but the restriction is that we have to stick with that direction while applying the nodal equation. You will see what I am trying to say. Okay, let us assign this branch current as I1, this branch current as I2, and this branch current as I3. Now you can just see that I3 is equal to I3 is equal to I because they have the same current direction. So I3 is equal to I. Now, what is the KCL equation that can be applied at this point, at this node? I1 is moving towards the node, I2, I3 are moving away from the node. So, I1 will be on one side equal to I2 plus I3 on the other side. Okay, so this is the basic KCL equation. I1 is equal to I2 plus I3. Next, it is a very important thing. Let us assign that the voltage at this node, let us assume that the voltage at this node be V subscript n. Okay, we don't know exactly what the voltage is, so we have assumed that the voltage at this node is Vn. Now, what is the equation or what is the formula for current in the current flow between 2 points? We know current flows from higher to lower potential. Okay, we know that. This is very important while applying Kirchhoff's current law in nodal analysis. So, current is higher voltage point minus lower voltage point divided by the circuit element present. Here there are only resistors involved, so we are using resistors. Vh minus Vl by R. If any other circuit element would have been present, capacitor, inductor, accordingly the equations would have been different. Okay, I in the capacitor I see is C dV by dt, and it is in inductor 1 by C dV by dt, and here it is dl by dt wave. So they will be different. For in this case, here it is simple, Vh minus Vl by R. Okay. Now, so here we have to apply this nodal equation using this concept. So, the nodal equation at this point will be I1 can be written as V minus Vn by R1. Okay, V minus Vn by R1. See, current I1 is flowing from V1 and is ending at Vn. It is originating from V, terminating at Vn. So, I1 will be V minus Vn by R1. In between V and Vn there is resistor R1. I2. Here it is Vn, here it is ground. Ground means 0 volt. So, I2 is flowing from Vn ending at ground. In between the 2 points there is resistor R2. So, I2 can be written as Vn minus 0 by R2. I3. I3 is simply I. Here, as it is given that this current is I, so we have to write it as I. Okay, is equal to I. This resistor, if it is there or not there, it makes no difference, because a current source in series with a resistor has no significance. Okay, a current source in series with a resistance makes no difference. That is, if there is a current source here and we have a resistor of any value, the current will flow through this resistor will still be I. So, this makes no difference. Okay, so this is the nodal equation. Now we have to solve it. Now, here we cannot solve it because absolute values are not given. Here the intention was just to make you understand how the nodal equations are written. So, we can simplify it. V minus Vn by R1 is equal to Vn by R2 plus I. Then you can do is that bring Vn on one side and express Vn in terms of V and I. You can do that. Suppose a question comes, we will deal with that later, but for now this is the basic nodal equation. Okay, the basic final nodal equation, and all the twists and changes that we can do depending upon the parameter which is being asked in the question, we can do it from here. Okay, so you have to remember some basic points while applying nodal analysis. First, identification of the node points. A node is a meeting point of two or more circuit elements. Next, assign node voltages. Assign current values and directions arbitrarily as per your choice, but the restriction is that you have to write the nodal equations in the same way, following the same direction and convention. The current always flows from a higher potential to a lower potential, so you have to write the expressions of the assigned currents in the same way. Next, you write the nodal equation, and depending upon the parameter which is being asked, you make the modification and changes. Suppose here we have to find out Vn, so we'll bring Vn on one side and express it in terms of the other variables. Suppose I is asked, then we'll bring I on one side and keep all the other values on another side and get the value. So that changes we can do. That's simple algebra. Okay, so this is how the nodal equations are written. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.